Hey guys, welcome back. So what we're looking at today is 6.3 leapfrog. So let's go ahead and jump right in. So for this first part, in each problem there will be a pre-image and several images based on the given pre-image. Determine which of the images are rotations of the given pre-image and which of them are reflections of the pre-image. If an image appears to be created as the result of a rotation and a reflection, then state both. So you're comparing all the images to the pre-image, by the way. So if we look at the pre-image, we have this shape here, our rectangle with the dot, and suddenly we go to image A. What happened? How did we go from this pre-image to this image? Well, we rotated it. So rotation. Now, how'd we go from the pre-image to image B? We also rotated it, just the other direction this time. What about image C? How'd we go from the pre-image to image C? Well, we flipped it over. It's a reflection. And what about image D? So in this one, we did multiple things, right? So we rotated it, got it up like this, and then we flipped it. So rotation and reflection. Rotate and reflect. All right, so be careful as to which one has two, but always compare it back to the pre-image when you do. You're just comparing. How did I get from this to A? From pre-image to B? From pre-image to C? From P-image to D? And these are all what's known as rigid transformations. So rotating, reflecting, translating, these are all rigid motion transformations. And rigid is your key word for this lesson. All right, reflecting and rotating points. On each of the coordinate grids, there is a labeled point and a line. Use the line as a line of reflection to reflect the given point and create its reflected image over the line of reflection. Hint, points that reflect along paths perpendicular to the line of reflection use perpendicular slope. So we want to reflect point A over line M and label the image A prime. So first we need to figure out what the slope of M is to make this easier. So the slope looks to be up 1, 2, 3 over 1. So we have a 3 over 1 slope. What's the opposite reciprocal? Negative 1/3. So that means from A, we're going to go down 1 and over 1, 2, 3. And then down 1 and over 1, 2, 3. And there, this point right here is our A prime. So it's at the coordinates 3, 1. So use the fact that these reflections need to be perpendicular. Find the slope of the line that you have. Then take and apply that slope. Find the opposite reciprocal. And then do that between point A towards your line and then past it to find out where that point's going to reflect to. So same idea for 4, 5, and 6. All right, for number 7, for each pair of point P and P prime, draw in the line of reflection that would need to be used to reflect P onto P prime. Then find the equation of the line of reflection. So lots of parts to this. So first off, we're going to take and find the slope between P and P prime. So up 1, 2 over 1, 2, 3, 4. So we have 2 over 4, which reduces down to 1/2. So if we go up 1 and over 2, that point right there is going to be on our line of reflection. Now, our line of reflection has to have the opposite reciprocal slope. So if we went up and over to get between P and P prime, it was positive. So the opposite reciprocal will be negative 2 over 1. So we're going to have y equals negative 2x. Now, from here, we're going to go down 2 and over 1, down 2 and over 1, down 2 and over 1. And come back over here and go up 2 and over 1, up 2 and over 1, up 2 and over 1, which tells us where our y-intercept would be. So this is 6, or this is 5, 6, and it'd be 1 above, so it'd be at 7. So there's the equation of our line of reflection. So that's what you guys are going to do for these, okay? So find the slope between P and P prime, find the halfway between them, and then do the opposite reciprocal slope. And then it's the same idea for 9 and 10, okay? All right, for the next section, for each linear equation, write the slope of a line parallel to the given line. Now, parallel means write what the slope is down. They have to be the same. Notice, in 13, it's not in slope-intercept form, so we don't know what the slope is. So we need to rearrange it. So we'd subtract 3x, so we'd have negative 2y equals negative 3x plus 8, then divide by negative 2. So we'd have y equals 3 over 2x minus 4. The negatives would cancel each other. So the slope would be 3/2. You literally just have to find what the value, what the coefficient is on the x. That is your slope. Now, for this next section, we want to write the slope that's perpendicular. So that means opposite reciprocal. So if we look at this one, opposite reciprocal of negative 2 over 7 is positive 7 over 2. There's our answer. All right, and our last section, we want to find the slope between each pair of points. Then, using the Pythagorean theorem, find the distance between each pair of points. You may use the graph to help you as needed. So, slope, y2 minus y1. So, y2 minus y1 over x2 minus x1. 1 minus negative 3 is 4. 1 minus negative 2 is 3. So 4/3 is our slope. Distance, 4 squared plus 3 squared equals c squared. This would make a triangle if we think about this. So we have 16 plus 9 equals c squared. That's 25. Take our square root, so c equals 5. Graph, if we plot these points, so we have negative 2, 1, 2, negative 3, 1, 2, 3. So this right here. And then we've got 1, 1, which would be this point right here. So if we make a triangle out of this, extend this side over. So this right here, 1, 2, 3. Notice that's your 3 and your slope. And then going up, wobbly line. 1, 2, 3, 4. Notice that's the 4 in your slope. So then the diagonal, the distance that we found, would be the hypotenuse of the triangle. So that was the 5. So that's 5 right there. So same idea for 18. You don't necessarily have to take and draw it out. If it helps you seeing it, by all means, you can draw out the triangle that represents, that's created from these 2 points, but you do not have to. All right, if you guys have any questions, feel free to ask. Have a great day.